Broadcasting around the world. This is Engineering Tomorrow, the podcast committed to bringing you the best in commercial construction, design, and engineering from the brightest minds in the industry. This is the stuff they don't teach you in school. So sit back, relax, and open your mind. You're about to get the insider knowledge to improve your next construction project or advance your career. This is Engineering Tomorrow.
Hello, hello, hello. Welcome to another episode of Engineering Tomorrow. I am your host again, Brian Gomsky, with Midwest Machinery in St. Louis, Missouri. Thank you again for being here. We have very special guests. I'm really excited about this. We've been working to get you guys on the show for a while. We are here with CannonDesign out of St. Louis, Missouri. Guys, thank you for being here so much. I know everyone's schedules are busy. Can you guys go ahead and around the room and introduce yourselves really quick?
Sure. My name's Mark McManus, mechanical engineer by trade, mechanical engineering group lead in St. Louis and office engineering lead. And with me we have Alex Oliver and Colin Hale. I'll let them introduce themselves.
I'm Alex Oliver. I'm a mechanical engineer with CannonDesign.
I'm Colin Hale, also mechanical engineer, and do a little energy modeling for Cannon as well.
Awesome. And as a bonus, we have the man, the myth, and the legend, Jeff Henderson, who is a sales engineer extraordinaire for Midwest Machinery.
Hello, hello. Glad to be here.
All right, I'm going to jump right in, guys. CannonDesign, who are you? What are you all about? Go.
We're an architecture and engineering firm, been in existence for over 100 years. We have offices from coast to coast and approximately 1,100 employees, architects and engineers, planners, and other service providers that provide solutions for our clients. We serve all major market segments, ranging from healthcare, sports and rec, civic, government, commercial, science and technology, and a few more.
So you guys are a little unique because you have a lot of like mechanical engineering firms. They just do mechanical engineering, but you guys kind of have like the whole package in one solution. Is that accurate?
That's right. We're a fully integrated firm. So we have the full suite of architectural disciplines as well as mechanical, electrical, plumbing, and fire protection and structural engineering. So we cover end-to-end solutions for all building types.
Okay. I want to go around the room. This is interesting. I've done this before. When you think of a lot of kids when they're in school or even in grade school, engineering, like I remember when I was in school, the Boeing engineers would come in and we do a month on stuff like that. And you think you're going to go into mechanical engineering and you're going to start doing fighter jets as soon as you get out of college. Obviously, you guys took a different route and you're doing a lot of HVAC design. I'd love to hear kind of your personal stories about what your perception was when you went into school, why you wanted to get this degree, and how you got to where you are today.
Yeah, my story is interesting. I think everyone has a personal story that doesn't end with what they thought they were going to do. My dad was an electronics technician in the Air Force. I was always good with math and science at school. I really liked space as a kid, so I thought I was going to design spaceships. Then as you mature and realize how hard it is to get to space and how few space jobs there are, then you start reality setting in. And I started out a co-op and summer internships with an automotive company and enjoyed it. But I actually found that I really was interested in what the contractors and the design firms on the other side of the equipment and systems being provided were. So then I changed and had a final internship with an engineering company, and then the rest is someone had to tell me what HVAC stood for. And
I hear that a lot, actually.
Yeah, and then the rest is history.
What does it stand for, actually?
No one knows.
I'll defer to my smarter colleague.
Guys?
So this is Alex Oliver. So I was always the kid that was always taking everything apart in the house, breaking everything along the way. Mm-hmm. I kind of naturally gravitated toward engineering. Went to school at Ohio University for mechanical engineering. Got out of school and didn't really know what industry I wanted to go into. I kind of had a little bit of a family background in the construction industry. My dad's a civil engineer doing bridges and highways. So I kind of naturally gravitated towards the more construction contractor kind of world. I always enjoyed the ability in the HVAC world to drive down the street and see a building that I've worked on and point to my kids and say, "Hey, Dad designed that." So I've kind of gravitated in that direction throughout my career.
But how did you take that first step into this specific niche?
So that's kind of an interesting story. So I graduated college in 2008, which was about the worst possible time to get out of school for
2006
a degree in engineering. So I actually took my first job with a major engineering firm doing power plant design.
Okay.
It was kind of this was the opportunity that was available at the time. As I started doing that, I was doing piping system design. I got to dabble a little bit into HVAC just out of coincidence. They needed somebody to do some work with some fan selections and duct sizing and things like that. Decided that I really liked that area of the work and kind of steered my career in that direction from that point out.
Okay. Colin?
Yeah, my path to HVAC engineering is very similar to both these other guys.
Cars or ships or
it was airplanes.
Airplanes,
yeah. So it's the prototypical airplanes. But even going back, it wasn't until the end of high school, and that's when I even decided I even want to do engineering. So it was a late start in terms of engineering. So got into college, went to SIU Edwardsville, and it wasn't until senior year that I even narrowed it down to, I definitely want to do turbines and propulsion or heat transfer, something with heat transfer. Then I had an opportunity to continue my education and started a master's doing some research in the bioengineering sphere, designing small lab on a chip scale processes. And so that is totally unique to what I'm even doing now. And so it wasn't until I started looking for jobs, started looking around the industry, and happened to know the lead mechanical at Canon at the time. And he said, "Why don't you come in and just see what we're about, see what we're doing." And at that point in time is when when I figured out that HVAC was something that was technically challenging and had the system integration piece that I was interested in doing.
Okay. What do you guys look for and I'm speaking to all you because you're kind of you're all veterans at this point, but what do you look for in a younger engineer wanting to come into this specific field? Or what can someone think about, attribute wise, what would make them a great engineer in this field?
Problem solving. So, we hire a lot of engineers from area schools. And by the way, I'm a Missouri University of Science and Technology grad. I forgot to mention that, representing that large faction in this part of the country. What we look for are decent GPA. You got to be able to do the coursework in order to substantiate, a minimum level of thinking and aptitude, of course. But it's more than that. We want to see, have you been in organizations? Have you got enough work experience that leads us to believe that you have demonstrated teamwork and problem solving. And once, that's the resume part, then we bring folks in and go through a couple of rounds and ask them, do deeper dives on their work experience, their desires. Do they like playing in a team environment? What are some examples of what they've done? So it's the engineering part of the job might be less than half. It's more as a younger engineer, but then as you develop, you have to do more teamwork, collaboration, communication, problem solving of non-engineering topics, logistical issues, and coordination with other service providers, such as the other types of engineers and firms that are needed to work on large-scale projects like we do, and then also the construction firms and then client relationships and making sure we're meeting their needs.
How do you draw that out? 'Cause you're spending maybe a couple hours with someone in multiple interviews. How can you draw that out of that person and really see if down the road this is really going to be a great person for this team?
Well, you cannot predict the future, but you can ask enough questions. And what I like to do is once I've done my process, I bring them in, and I have them spend most of their time with the rest of the team, getting a tour, asking more questions. And then when the process is over, I gather everyone's input, and then you get a pretty good idea. We've been really successful with this process, and we've got a great team.
Great. So I want to jump into the meat of why I'm so excited about this episode with you guys. You worked on a highly top secret reverse engineering UFO base. And by the way, I'm a huge Joe Rogan fan. He's had a lot of these guys on, like Bob Lazar. And I'm really hoping to get some bombshell stuff from you guys today. Is that accurate?
We can neither confirm nor deny whether we worked on alien technology.
All right, fair.
Did you see them aliens?
Not quite, but it is a sophisticated client. It's Johns Hopkins University Applied Physics Lab campus, and the project was new lab building 201. So what Johns Hopkins Applied Physics Lab campus does, and this is different from their medical and academic campuses, which are also widely popular, they do material sciences, air and missile defense, biomedical interfaces, satellite instrumentation technologies, and communications. So they are on the forefront of R&D for these fields, and many of the specific topics that they research are unknown to us, but they are cutting edge research. And I'd actually refer all of your listeners to jhuapl.edu and read up on what they do. It's absolutely fascinating.
Yep, I have the site pulled up. They do homeland security stuff, precision strike, sea control, special operations. I mean, this is the real deal, as serious as you can get type lab.
One of the first things that you recognize when you drive into campus is the approximately 40-foot diameter antenna that is used as mission control at their facility. So at their facility, this campus, they host mission control for the New Horizons mission, which if you watch NOVA, like all good engineers do,
of course,
in January, the New Horizons mission reached and imaged the first Kuiper Belt object beyond the solar system. So those activities occur very close to this job site.
Completely amazing. Before we even get into this, how did you even hear about this project? How do you get involved in something like this?
So relationships, like any business development, it's people like working with people at the end of the day, competent people they feel comfortable with. When the opportunity arose, we had employees at CannonDesign with prior relationships and project history with the Applied Physics Lab campus. We were invited to compete for a concept study. We were awarded and produced a product that we presented to them that was approved and led to the engineering and architecture, a real project of designing this building, which we then competed for and were also awarded. And it's relationship-based. So not only do you have to have the expertise, obviously, but it's a story of having some history, understanding clients, demonstrating your performance, good performance, not just having it on resumes and having references. So can't understate the value of doing good work, but maintaining great relationships with all of the service providers and your teaming partners, because it takes more than one AE firm to pull off any large project. And now we're into probably the second half of the construction phase, and we're working hand in hand with the contractor and the owner to bring this project through the finish line.
When I think about Johns Hopkins, I think about the medical school and where doctors go. So how does this, you're talking about the New Horizons and space and defense, how does that relate to the university side?
They have three campuses that all have distinct missions. The medical school is only one of those. The Applied Physics Lab, which is the campus that we're working on, is in another part of Maryland, probably about 30 minutes from the Baltimore campus with the medical school, and their mission is primarily physics-based research and development.
As engineers on this project, does this type of project excite you more than others, or are they all kind of like exciting?
this is a fantastic project. You don't get an opportunity to work on this kind of research and development lab space with this big a variety of high-end, cutting-edge labs, very often.
Yeah, you mentioned their website, and you mentioned all the cool things that they're doing. To partner and work with a client to develop a building that does that kind of research, that's what we all look for. Those are the projects that we all get really excited about at the end of the day.
I can imagine. I mean, Jeff, even as a sales engineer, like something like that would be really cool versus working on like a dairy processing plant or something like that. Not that we don't love dairy. We're in the heartland. Farmers, if you're listening, we love the dairy. I'm just saying.
To be honest, I literally thought this was at the medical school until the very end of the project.
Well, they couldn't tell. They were under non-disclosure, so
right.
They probably said it at a Starbucks or something. Who knows?
Alex kept winking at me every time I'd give him a selection. I didn't know why.
All right, so let's get into a little bit more meat about what this project is. We know you obviously won the project and worked on it. Let's talk about at a high level what this building is, or what you even know it is, and what could they even tell you about what this building was? And was that a challenge?
So starting a project of this scale involves user group meetings. There's a development of a program. This particular building hosts several groups within the organization that have different areas of expertise and targeted research. So that they work with our lab planning architects to determine a space program that then gets turned into a blocking and stacking, a massing of the building. There's some back and forth with the client to make sure that the aesthetic and all the goals of the building are being met, and then we start applying physical selections and space planning from the engineering side of things to make sure our mechanical rooms, our electrical rooms, water entry, fire pump room, everything has a space for it and can be accessed easily for maintenance. And then the types of specific areas in the building will include wet chemistry labs. So that's if you envision folks in lab coats with Erlenmeyer flasks and doing experiments, that type
making
of
potions and blowing
wet chemistry versus a dry lab, which this also has a lot of dry labs. Dry labs can be any sort of a physics-based lab, computers, robotics, lasers, R&D that's not based on something that is dissolved in something else. So there may be fewer fume hoods depending on what they're doing in there. This client had a lot of different space types than we normally see in a typical lab project, such as dry rooms that needed exorbitant dehumidification. They're a dry room, ultra dry room, ultra dry room, and I'm not making that up. There were relative humidities that were so low that they are not able, you cannot achieve those without in a very specialized enclosure, specialized dehumidification equipment. And then at the end of the day, it's got to be specialized processes, operational processes, such as, if you open the door and close it, it may take hours for that room to stabilize back to where it's supposed to be before you can start an experiment. So there are a lot of specialty applications in the building, and then laser labs with help of filtration.
We've got a wide variety of laser labs. They have material science labs that have, we've got a full metal shop. We've got H3 hazardous classification rooms, which is for storage of hazardous flammable and solvent materials. So there's special exhaust systems and special construction techniques that have to be adhered to with that. And in addition to that, we've got a 4-story atrium in the middle of the building. With a massive engineered smoke control system that's all got to interface with the lab and maintain operations of the lab while the atrium smoke evacuation system is in operation.
Oh, wow.
Another special feature of the building is a data center. Now, a lot of buildings have data rooms. This one had a larger than typical data center. And then the nature of the work requires secure and non-secure networks. So not only did we provide the mechanical, electrical, plumbing, structural engineering on the project, we also had a lead technology services engineer from our firm that designed the data center, all of their low voltage systems, security, closed circuit television, and all those items. And then energy features. Colin, you want to touch on those?
So some of the energy features of this building would include a 180,000 CFM runaround energy recovery loop.
Okay.
This is the largest one we've done in a long time. Might be the largest one we do in a long time.
Mm-hmm.
It's tied in with 9 air handling units, and on the air handling units that serve the atrium that Alex mentioned, they're featuring enthalpy wheels. So every air handling unit in this building is going to include some form of energy recovery, and that rolls right into LEED and the goals of the project, which we haven't talked about yet. But one of the goals of the project and one of the requirements of the permitting process was to get LEED certified, and this building is currently targeting a LEED Silver rating.
What does that mean, and what are like the different levels of that?
So there's 4 levels of LEED certification. There's LEED certified.
Okay.
There's LEED Silver, LEED Gold, and LEED Platinum, and they are based on a scoring system that LEED publishes, and each one has a number of credits that you need to demonstrate compliance with. A big driver of LEED is showing that you're more energy efficient than the ASHRAE standard that they're referencing.
Okay.
And this project was permitted under IBC 2015, which incorporates by reference IECC and International Energy Conservation Code 2015. So this was the first IECC 2015 project for this campus, which drove the need for energy recovery for non-lab spaces that they had not needed before. And in our case, we used full enthalpy energy recovery wheels in our non-lab air handling units.
So what is the difference between LEED and code?
It's a good question. LEED is a third-party certification process that ensures that the buildings are performing well, both from an energy and a comfort perspective. It looks at the material selection for the envelopes. It considers recycled content. So it's a sustainable green third-party certification, whereas the codes, particularly the energy code, is something that is mandated by law by the municipality that needs to be complied with.
I think a lot of people know, working with codes and inspectors and all that, how does the process work with LEED?
It's a little different, but it's got similar aspects.
Okay.
So LEED, there's really there's 2 main paths that you can try to comply with LEED. There's a design and construction package together, where you will submit these credits and prerequisite requirements with the construction team and the design team in one process. And then there's another that allows the design efforts to be split from the construction. They all need to be submitted in the end to get certification, but it just breaks up the process. And that differs a little bit with energy code compliance, which will be done at the permit stage of the project.
And how do we show energy code compliance?
So on IECC, there's 3 major compliance paths. There's the compliance path that you would follow all the stated mandates of this code, and they term it the prescriptive path. And that's just a series of checkboxes that you need to design around to show compliance. The second would be using an energy model to show that your building is 85% of a baseline building as defined by the code. And then the third allows you to use the ASHRAE 90.1 standard that helped inform this version of the IECC code. And under that one, there's 2 other compliance paths, the same energy modeling or the prescriptive method.
How does energy modeling work?
It's a lot of wizardry, and a lot of long nights. So it's a process that you build the geometry of the building. You define all the HVAC.
Is this in some sort of software that you're talking about?
Yeah.
Okay.
So there's a number of softwares available. There's some free, some paid, and they're all really good. They all do what they're supposed to do, and that is to help define how much energy this building consumes. So the process is you'd build 2 models simultaneously. You'd have one that is the baseline, which is defined by whatever standard or code you're referencing. And the second is to accurately define what the proposed or the actual building you're building. You'll build the geometries, you'll define the systems, you'll set schedules, all those things, and you'll run your model, and you'll see how they compare. The end goal is hopefully your proposed building is performing substantially better than your baseline.
Are you building, like when you use this energy software, are you building a visual 3D model, or is it all just math and numbers?
Some of them have 3D software components. Some don't. The one we use will produce a 3D image, which is always helpful to showcase to our owners that we're not just making up this building to show compliance, but here's your building that we're modeling.
Okay.
It's also important to know that the code compliance portion of this gets submitted with the permit drawings for the authority having jurisdiction that provides the permits and then ultimately the certificate of occupancy. So that occurs early, but the lead documentation supporting calculations and can occur throughout construction and be completed at some point after that when everything is finalized.
You're listening to Engineering Tomorrow, always striving to bring you the best in commercial construction, design, and engineering.
So I'm really interested. It sounds like you've done a lot of unique pieces within this building. Maybe you've done those pieces before, maybe you haven't. When you have a client, not even just talking about this one, who says, I need this, room with these extreme conditions. And by the way, no other building in the United States has this. How do you even ensure that what you design is going to work? Do you kind of just throw it to the rep and then you can throw them under the bus if it doesn't work, or how does that work?
Only when Jeff's on the job.
Only when Jeff's on the job.
That's correct. I can confirm
You
that.
give Jeff all the parameters and say, it's your butt if this doesn't work.
Correct.
That's an interesting philosophical question. We want to be progressive. Energy's a big deal, especially with a institution such as this that uses a lot of the nature of the facility uses energy. We want to recover that, but we don't want to add too much maintenance. This is a mission-critical facility, so there was redundancy on all the mechanical components. So there's an extra boiler, an N+1 boiler, chiller, one of the fans in the high plume laboratory exhaust fan array is a redundant fan, and so forth. So not only is efficiency important, but robustness, reliability of their process. Because some of their experiments can span days or weeks for all we know. We know that they wanted these features. So how do we do this and provide cutting-edge energy efficiency? Well, we do rely on sales reps to keep us informed of all the latest in what's going on. It's hard for individual design engineers that do what we do every day and need to be working on our projects to make money for our firms to also have enough time to stay on top of everything. So we do rely on outside forces to bring, like Midwest Machinery, to bring us new information about their products and equipment. We work with the owner to find out what their thresholds are for certain more progressive types of systems. We want to make sure they're comfortable using the systems we provide, and then through that cooperative dialogue, we hone in on what the most appropriate solution is.
So, like in the instance of the ultra low humidity room, maybe you've done these before in the past, but let's say you hadn't. How do you ensure that it's going to meet what they want? For
that particular application, these are one-off things that we're stick building, and we don't have.
Yeah, for sure.
It's pretty rare with a firm like ours with 1,100 employees that we don't have experience in the firm.
Okay.
Now, sometimes that experience exists just outside the project team, and we pull those people, and we have ways to share information and processes within our firm to do that. But having, say, an envelope for this dry room, we have experts within the firm that have enough history with the building materials that we can tell them what kind of permeance. So we work together. On a room like this, it truly is a multidisciplinary exercise to come up with the solution. So our architects will present us with what they've been able to find, coatings and a system, that they found through their service providers that can provide a certain level of permeance that we're looking for. If there are other features that are needed, such as a washdown surface or not washdown surface, we work that in, and then we mate that with equipment that's readily available to dehumidify. And then we talk about other operational measures. It's important for us to understand how they're going to use the room. It's extremely important, not necessarily what they're doing in the room, but how they're going to use it. Do we need a vestibule? How fast do you need this to recover? Because if they want a fast recovery time, we'll have to add additional mechanical equipment in order to do that. We need to learn more about how they're going to use it, and then we find a solution. But if you break this up into tiny pieces, there's really not any one piece of it that's never been done before. So we integrate what has been done before, but in a different way perhaps for this client who wants a very special room.
And on the challenge, do you guys as personally on these engineering challenges, is this the stuff you guys live for? Like, is this the stuff you get excited about? And even Jeff, I'm gonna ask you that, these extreme cases, is that the stuff you guys like to work on?
I'll tell you personally, and I want to hear everyone else's take on it as well, but yeah, there are easy jobs and there are challenging projects, and the technically challenging projects are the fun ones. Sometimes it's, you wake up knowing you've got a big hill to climb, but you work really hard, you leverage the collective strength of the firm, and then you come up with a solution, and then you present that to the clients, and they're happy with it. That is what I get up in the morning to do.
Oh, absolutely. I couldn't agree with Mark more. Those types of spaces, particularly on this project, where we did have a wide variety of unique spaces, a wide variety of systems and equipment that we hadn't necessarily integrated in the same manner as what the client was asking for. Those are the most technically challenging and also the most fun projects to work on. We could do, plain Jane vanilla spaces all day long, and there's certainly a time and a place for that. But these type of projects where you're doing something more unique, something more extreme than you necessarily would do with your standard office space, VAV boxes with hot water reheat kind of project, those are the projects that I get up in the morning and look forward to working on the most.
Colin?
I would agree. The fun part of these is the iterative approach that you have to take. So it's working through the solution multiple times, and the first time maybe you're not right. Maybe you got to work through it 2 or 3 times, and you got to work through it with the owner a couple times to make sure that they're in agreement, they're on board with it. That's the fun part. The fun part is figuring out how through the course of those iterations.
Jeff, how does this look on your side where you're selling equipment to them, especially in these unique situations with these crazy parameters? Is that stressful? Is that what you love doing? Tell me about your personal stance on that.
Yeah, I'll echo what they were saying. A little bit differently from my point of view, but like Alex said, there's the vanilla projects that you do day in, day out. But when you have a project like this, that has got its own host of different problems, it's a lot more fun to try to find a solution, and then when you actually see that solution put into place and it works, is very satisfying. I know we had one thing, an example on this project was the cooling tower and the pumps and the net positive suction head, because the pumps.
What does that mean for some of us?
Net positive suction head is what a pump requires at the suction side, so it doesn't cavitate.
Okay.
So when you have an open system with cooling towers and pumps, you need a certain amount of net positive suction head at the suction side of the pump. And if the cooling towers are equal or just slightly above the pump center line of suction, then that is something that needs to be looked at. And on this project, the pumps were right even with the level in the cooling tower. So we definitely had to look at something to make sure that those pumps weren't going to cavitate on this project.
Yeah, as far as the particular system itself, that was something that we really had to work together with Jeff and with our in-house architecture teams and structural engineers to come up with a solution. What we ended up doing is basically the cooling towers were installed in a well on the roof of the building adjacent to one of the penthouses that contain the condenser water pumps. And what we ended up doing is we worked with our structural team and architectural team to develop a raised platform system to get enough net positive suction heads so that we did not have issues with the condenser water pumps. And those are the kind of things, that I know I really enjoy as part of CannonDesign, with us being a fully integrated firm. I'm sitting there at my desk working with structural engineer right next to me, project architect, on the other side. We're sitting down really working together to come up with the best solution to solve the problem in front of us and give the client the most effective system we possibly can.
Mm-hmm. I want to go back to what we are calling the vanilla projects. Those might be a little bit of an unfair descriptor because those projects are very important. And a lot of our sophisticated clients and important clients have come back to us for projects that are sometimes less sophisticated. Mm-hmm. But they come back to us, and because we've already developed the rapport with them that they know they're going to get a good quality product, and these projects are also important to help integrate a whole new generation of staff to learn certain technical aspects of the job, and so you really need a blend of sophistication, non-sophistication, and other types of projects to make the business work.
Mm-hmm.
Well, and the system types and the systems that get put together for these sophisticated jobs help inform the next less sophisticated project to help them become even better the next time. More energy efficient, more productive, higher levels of comfort for the space.
Yeah, to add on what Mark said, maybe vanilla is probably the wrong term. Maybe you said it, less sophisticated, because all jobs are sophisticated. Yeah. All jobs have their own host of problems that you can encounter, and they're all different. And you've got to apply what you know and bring in other people on every project. So there's no job that is just a walk in the park.
You can go in. I mean, even what you may consider a basic office, people screw up the engineering all the time. Maybe it's too hot in 3 of the rooms, or they don't account for the right loads. It's like it still takes a lot to get it right. Even if the building itself is a plain office building, you still have to have a great engineer that's going to make sure it's put together correctly so the people on the second floor aren't sweating profusely, all day or whatnot. How does it work? You guys are doing work in different states, maybe different countries. Every state's got different codes and different compliance. How does that challenge look, and how do you overcome that?
We have to know what codes are in effect and any variations that may be adopted at the local level. For example, Missouri does not have a statewide building code. Mm-hmm. Every code is adopted by the local authority having jurisdiction, usually the municipality, and then in the case of St. Louis, unincorporated St. Louis County, the county then governs all of the codes in effect for non-municipal portions of St. Louis County. Illinois, for example, has a statewide energy code, and we just have to go state by state, and you start at the state level, look on their website. If you're starting from scratch, you go through these steps of going to the state level. If it's a federal project, you have to look at all of the federal guidelines for that particular division of the federal government you're working for, and then down to the municipal level, who may adopt amendments to the statewide codes. It helps that we have offices all over the country that can get us started, but you always have to do a code search at the beginning of a project to make sure you are complying with the latest that have been adopted, because some could be adopted very recently, and you wouldn't know that from a website unless you do a little more digging. In this case, for the Hopkins project, it was all in Howard County. We have a D.C. and a Baltimore office, and we were able to get through that pretty quickly.
So you've got the codes. You've got everything looking good on paper. At that point, does someone with the municipality then look over everything and make sure it's good, or they don't tell you until it's built you screwed up?
No. Oftentimes, with the agreement with the client, you may send an early package to the city or county or the authority having jurisdiction to alert them of the project. You generally want to do that in not only to let them know what's coming down the line, but also in goodwill you're doing a major project in their area of influence, you should be talking to them as it affects them. So for goodwill purposes, but also sometimes to get into a queue, to make sure the permitting process goes smoothly, to not drag construction out. So there are a lot of reasons, but you want to do that in concert with the owner's agreement so that they can control it's their building. They get to advise how soon they want to go to the authority having jurisdiction.
Mm-hmm. So you mentioned you had offices nearby the construction site. How does Canon then collaborate on projects with different offices?
So we use a process called syfmo, which stands for Single Firm Multiple Office.
Okay.
So the Johns Hopkins project is a really, really good example of that. In any particular office, we may have architectural expertise in lab planning, or architecture, or mechanical engineering lab type space expertise. In the specific instance of the Johns Hopkins APL project, we had design teams from all over the country working on this. So lab planning and project management were in Washington, D.C. Design architecture and technical project architecture were in Chicago. Electrical engineering was in Buffalo. Structural engineering was in Buffalo. Mechanical engineering was in St. Louis, and plumbing and fire protection was also in St. Louis. And really what we try to do is we try to appoint the best people that are available for the project type at the time. So this project was such a high-profile, highly complex, very important project to the firm that we brought in the best of each discipline from across the country to work together to bring the best amount of expertise to the job.
Okay. So organizationally with CannonDesign, you get this awesome, huge project. You got offices everywhere. Who's the end-all, be-all of managing the project, and how do you determine who's lead on this project?
It's back to the relationships conversation. We have a client leader. That client leader starts the process and then loops in other leaders of different disciplines, whether that be architecture, MEP, services, and then the collective brain trust will then start to build the team. But largely that team is built during the proposal stage because we want to show them during as we are competing and trying to convince our clients that we are the best ones for the job. That team is largely established then.
So do you guys have like a board of directors or what is that? What does your organization kind of look like in that regard?
Well, we have a CEO, a core team, which is essentially an executive committee and a board of directors.
Okay.
They can be part of project pursuits and project execution, but not necessarily at the project level. It starts with the client team leader. So there is, for every major client we have a client team leader, and then it disseminates from there. And they loop in engineering leaders, architectural leaders to put together this project. And we pan the entire firm to make sure we put the best people on each project.
Okay. Is it more of a challenge, especially on this project, if you have a room where they're like, well, we can't tell you exactly what we're going to do here, but we just need to make sure that it works how it needs to work. Is that a challenge, or is it pretty not a big deal? How does that work?
It can be a challenge. A lot of times it's a discussion with the client about, okay, if you can't tell us the specifics of what you're doing in the room, maybe you can tell us a little bit more about, what kind of environmental conditions you want to maintain. Do you have fume hoods in the space? What kind of types of equipment, maybe not specific applications, but what types of equipment? Is this going to be the type of space where you're trying to maintain, 75 degrees and 50% relative humidity, or are you trying to maintain really low temperatures, really high temperatures, low humidity, high humidity, trying to parse out, without them necessarily telling us what the exact science is or what the exact application is, but what types of equipment we need to handle and what types of conditions we need to maintain, so that they can, it's just more of a discussion, more of a back and forth, as opposed to a more prototypical space where we don't need quite as much input from the client on the particulars of what their desires are for the space.
Yeah, particle counts are another one. If they can tell us, like Alex said, room conditions, are there any prescribed air change rates for some reason, particle counts, we can help them back into some of these things if they can describe in general terms what they're looking for. And then different pieces of equipment have different utility connections. Are they mechanical heat rejection things, lab things that need water cooled connections, lab gas utilities? Does it need nitrogen? Do we need fume hoods? Do we need to exhaust off something from a burner? If they can tell us these things, they don't really have to sacrifice any proprietary information, and we can give them a space. And usually they have something in mind, like we need a bench this long. This bench may have this, or this, and it needs to be somewhat flexible. But we do that all the time. So if they can give us enough information, we can give them a space that's flexible enough for their needs and continues to perform.
On a building this size, let's say it's done, and they're right about to flip on the electricity, turn on the water, turn on the gas. How much involvement do you guys have at that point? And what does that process look like now that we're ready to go and we're a week away from people moving in?
It's a great question. As the design engineer, you're still involved.
Okay.
You're there to help answer questions about any issues that might have arisen when startup happens. But at this point in time, we'd encourage people to have commissioning agents as well who act as a third party to help get the building to operate as it was designed.
Okay.
They're there as a resource to the owner and even as to the construction team to be that technical expertise in getting the systems to operate properly.
How, on average, maybe for a building this size, how long do you think it would normally take to get everything optimized?
On a building of this scale, it could take a while. It could take a couple months, and you have to phase it properly with the construction schedule. So air handlers might be ready before the chillers. So how much of the air handling units can you test without chilled water? You might be able to do 60% of it. You might be able to do 20% of it. So those commissioning agents can help stage their plans in such a way that it works with the construction schedule, meets the owner's end goal of, we want to be in this building doing science on this day.
And what is it? We talked a lot about the design and engineering. What does your involvement look like with the contractors actually doing the physical building through this entire process?
So we're still very much involved. You
Okay.
know, the contractor, the plans and specifications detail out a wide variety of submittals, coordination drawings, things of that nature that we're anticipating to see from the contractor. So there's always a level of coordination to make sure that what equipment and materials are going to be purchased actually meet the project requirements, as well as we do regular site observations. I was actually in Baltimore at the Johns Hopkins APL project earlier this week to do what we're doing on that project, which are biweekly site observations, where we sit down, go on site, walk through the space, note with the construction team any issues or items of concern that we have, and sit down and answer questions that any of the contractors, whether that be the controls contractor, the mechanical contractor, or the general contractor, work through specific issues and coordination items. We're right there at the table through the whole process to help make sure that what gets built, number one, actually will work, and number two, will meet the design intent.
Good relationships also apply during construction. This project is large enough that we cycle through several team members to go out and make site observations. Different people will see different things, and so there's actually value to having a different set of eyes go out there and log things. Having a great relationship with the build team is important, because once you have that understanding that you can talk about problems and resolve them quickly, decisively, find no-cost solutions to things, it benefits everybody. It truly is a win-win.
What is the ideal process and collaboration from start to finish to ensure that a project goes very smoothly, working with all the different entities? Give us some tips that we could throw out there for people.
If there's one piece of advice I could give, especially to all the architects listening out here, is bring the engineers in early. If you think it's too early, we'd like to be involved no matter what. even if there's one discipline that's working through, say, architectural blocking and stacking, all of the different disciplines have different priorities, different needs, particularly for space, adjacencies, things of that nature. And we're all pushing and pulling in different directions to achieve those needs, but we're all working together to come to the same end goal, which is a building that works for everyone.
Guys, this has been a amazing episode. I am super excited about Johns Hopkins APL coming to fruition. This is definitely going to be a showpiece for them as well as it probably is for you guys. What final words of wisdom can you throw out there today?
Yeah, I think the last thing I could think of would be just it's incredible to work on a project like this that has such technical needs for the space as well as having a high level of energy efficiency. That's fun. It's enjoyable. It's what we wake up to do every day.
No, it's been really great to talk about the project, talk about CannonDesign and all of the industries we serve. We really have a lot of fun with projects like this, and we've got some interesting ones coming down the line. So go to our website, CannonDesign.com, and learn about us. But thank you for having us on. This has been a real treat.
All right. Sounds great. Thanks again. And to all you listeners, keep engineering for tomorrow today.
Thanks for joining us on Engineering Tomorrow. If you liked the show, please take a moment to subscribe on iTunes or Spotify. For even more great engineering or construction knowledge, visit engineeringtomorrow.blog.